Curious about the secrets hidden behind the world's most intriguing mysteries? You're in the right place. Today on Unveil the Facts HQ, we're revealing some of the most mind-blowing facts that will leave you questioning everything. Make sure to subscribe to our channel. 1. Black holes can slow down time. The immense gravitational pull of black holes doesn't just trap matter, it also distorts time. According to Einstein's theory of general relativity, as objects get closer to a black hole, the fabric of space and time bends. This means that time slows down dramatically near a black hole, a phenomenon known as time dilation. For someone watching from a safe distance, an object falling towards the black hole would appear to move slower and slower, almost as if it's frozen in time. If you were near the black hole, time would still seem normal to you, but to an outsider, you'd seem to be moving in slow motion. This mind-bending reality highlights just how strange and extreme the conditions around black holes are. This time distortion isn't just theoretical, it has implications for our understanding of the universe. If astronauts could somehow survive near a black hole, they could theoretically experience minutes while centuries passed on Earth. This bizarre interaction between gravity and time reveals just how interconnected they are. Black holes give us a glimpse into the ways that extreme environments can stretch and warp our basic understanding of time, making them one of the most mysterious objects in the cosmos. 2. Black holes can be as small as an atom. When we think of black holes, we often imagine massive celestial bodies. But black holes can also be incredibly tiny. Some theoretical physicists believe in the existence of primordial black holes, which could be as small as an atom. These black holes are thought to have formed shortly after the Big Bang, during the chaotic and dense moments of the universe's creation. Despite their tiny size, these black holes can contain a mass greater than a mountain, meaning their gravitational pull would still be enormous. Though we haven't yet observed these mini black holes, their existence would open up entirely new dimensions to our understanding of both black holes and the early universe. Primordial black holes could help explain some of the universe's biggest mysteries, including dark matter, which makes up a significant portion of the universe's mass, but remains undetectable. These mini black holes could be scattered throughout the cosmos, lurking invisibly until we develop the tools to find them. 3. Nothing can escape a black hole, except information. One of the defining features of black holes is that once something crosses the event horizon, it can never escape, not even light. However, the groundbreaking work of physicist Stephen Hawking challenged this notion when he proposed that black holes might emit radiation, now known as Hawking radiation. This radiation allows black holes to lose mass over time, suggesting that black holes could slowly evaporate. What makes this even more fascinating is that if black holes can emit radiation, it raises the question of whether information, which was thought to be lost forever in a black hole, could also escape. This leads us to the unresolved black hole information paradox. According to quantum mechanics, information should never be destroyed, but in black holes, it seems to disappear. 4. Black holes can merge. When two black holes get close to each other, they can begin a gravitational dance that eventually leads to a violent merger. This process doesn't just create a larger black hole, it also generates gravitational waves, which are ripples in space-time. These waves were predicted by Einstein, but only confirmed in 2015 when the LIGO Observatory detected the first signals of two black holes merging. The energy released during these collisions is immense, momentarily outshining entire galaxies. These events are rare but powerful, offering scientists valuable insights into the nature of gravity and space-time itself. Gravitational waves allow us to observe the universe in a completely new way, giving us the ability to detect events that are otherwise invisible. Through these waves, we can study the black hole's properties, such as their mass, spin, and distance from Earth. 5. They can eat stars. Black holes are not just passive objects floating in space. They actively consume any matter that gets too close. When a star ventures near a black hole, the gravitational forces become so extreme that they can rip the star apart in a process called stagnification. This is because the pull on the star's side closest to the black hole is much stronger than on the far side, stretching the star into a long, thin shape before it's torn to shreds. The remains of the star are then pulled into the black hole, adding to its mass, while some of the material forms a bright disk of gas swirling around the black hole's event horizon, releasing intense bursts of energy as it spirals inward. These star-eating events provide astronomers with an opportunity to study black holes more closely. As the material from the star heats up and emits X-rays and other forms of radiation, telescopes can observe this activity and gather crucial data. 6. There are different types of black holes. Not all black holes are created equal. There are several different types, each varying in size, formation, and behavior. Stellar black holes, which form when massive stars collapse, are the most common and typically have masses between 5 and 100 times that of our Sun. At the other end of the scale are supermassive black holes, which exist at the centers of most galaxies, including our own Milky Way. These behemoths have masses millions or even billions of times greater than the Sun, yet we are still uncertain about how they form, whether they grow over time by consuming stars or merge with other black holes. Beyond stellar and supermassive black holes, there may also be intermediate mass black holes, which fill the gap between these two extremes, though they are difficult to detect. Additionally, primordial black holes, mentioned earlier, could have formed in the early universe and might be much smaller than their more well-known counterparts. 7. The closest black hole to Earth is just 1,500 light-years away. While black holes often seem like distant cosmic phenomena, one of the nearest known black holes, part of the HR 6819 system, is only 1,500 light-years away from Earth. This system, located in the constellation Telescopium, was discovered in 2020 and surprised scientists with its proximity. Although 1,500 light-years might seem far in astronomical terms, it's practically in our cosmic backyard. This black hole's discovery has reshaped our understanding of how common black holes might be, suggesting that there could be many more lurking nearby that we have yet to detect. The HR 6819 system also shows us that black holes can be part of multi-star systems without exhibiting the dramatic energy releases we often associate with black holes. This hidden nature makes detecting nearby black holes a challenge. 8. Black holes might be gateways to other universes. Some scientists speculate that black holes could be more than just massive objects that consume everything around them. They might be gateways to other universes. This idea is based on the theoretical concept of white holes, which are the mathematical opposites of black holes. While black holes draw matter in, white holes could potentially expel matter, creating a passage between different parts of the universe, or even linking one universe to another. This forms the basis for the intriguing but speculative concept of wormholes, which are like tunnels through space-time. Although this idea remains theoretical, it has captured the imaginations of both scientists and science fiction writers. If black holes are indeed connected to other regions of space-time or different universes, they could offer an unprecedented way to explore the cosmos. 9. Black holes can spin. Black holes aren't just static, non-moving objects. Many of them spin at incredibly fast speeds, a result of the angular momentum they inherited from the stars they formed from. These spinning black holes are known as Kerr black holes, and their rotation can distort space-time around them. The faster a black hole spins, the more extreme these distortions become, creating a region known as the ergosphere, where energy can theoretically be extracted from the black hole. This spinning motion also impacts how black holes interact with the matter and light around them. The idea of a spinning black hole adds another layer of complexity to these already enigmatic objects. As material falls into a spinning black hole, it forms an accretion disk that swirls faster and faster, generating intense radiation. 10. black holes could one day disappear. Despite their seemingly eternal and unchangeable nature, black holes might not last forever. Over incredibly long timescales, black holes could eventually evaporate through Hawking radiation, a process that allows them to slowly lose mass. This evaporation process would take longer than the current age of the universe for most black holes, but in theory, it means that black holes will eventually shrink and disappear. For smaller black holes, this process would occur more quickly, while for larger, supermassive black holes, it could take trillions upon trillions of years. The idea that black holes could one day disappear is mind-blowing, as it suggests that even these seemingly indestructible objects are not immune to the passage of time. If Hawking radiation is proven correct, it could lead to the ultimate fate of black holes, where they shrink down to nothingness. Fascinated by the mysteries of the universe, there's so much more to uncover. Make sure to like the video. Be sure to hit that subscribe button and drop a comment below with your thoughts.